Let's pick up the story from where we left off in the last video. You have reached a steady state, which is to say that small k no longer changes on its own. So, just to briefly recollect the story so far. So you have small k here, various quantities on the y-axis, and you probably started from here and you reached this point, or you started from here and reached this point. You now are at KSS. Whatever has to happen has happened, and we'll analyze this process. It's called transitional dynamics in more detail in the next video. But in this video, you're only going to look at a world where steady state has already been arrived at, however that way of arrival is. So once you've arrived at the steady state, note a few things, right? By definition, k does not change anymore, right? Which implies that small y and small c also, and small c here is consumption per worker, also do not change anymore. Which is to say that this economy has no hope of long run sustained increases in living standards, because output per capita is going to stagnate after a while. So till you have reached steady state, sure, k, small k increases, small y increases, small c increases, but eventually you're going to reach the steady state, and after that these things can no longer change. The second result, capital K is equal to small k into L, right? Which implies that capital K dot by K is equal to small k dot by K plus L dot by L. Now this is equal to 0 beyond the steady state. So this is equal to L dot L at steady state, which is equal to N, as we have seen earlier. Similarly, capital Y equals small y into L, which in turn is equal to f of k into L, which implies that capital Y dot by Y is equal to this, and I'm not differentiating this further, plus L dot by L, because this whole thing equals 0, because small k is no longer changing. So this is also equal to L dot L, which is equal to N. So Y, K, C grow at N. So aggregate output, aggregate capital, aggregate consumption are still growing, and they'll continue to grow forever. But then they are driven by population growth. But of course, all this increase in aggregate output is being met one-to-one by the increase in population, which is why living standards are not increasing. Okay, two important results already out of the way. Third result, S has only level effects and no growth effect. It's just an effect. Okay. So what is a level and a growth effect anyway? For a variable like small k, a level effect is defined for a parameter. Right? And I think I've spent a lot of time in the comparative statics video explaining how steady state values of small k are determined by various parameters. So a level effect given that parameter means that the steady state value of that variable changes when that parameter changes. So level effect of x with respect to parameter alpha means it's just equivalent to saying existence of such a level effect is equivalent to saying that the steady state value of x does get influenced by the value of alpha, right? Growth effect then Um, growth effect means growth effect of x with respect to this means that growth rate of that variable in steady state depends on alpha. Okay, so S has only level effects and no growth effects on small k. Why? Because note, right, when S increases, small k in steady state increases. This is something we have seen again in detail with rigor. But the growth effect doesn't change because small k dot by k is always going to be 0. Right? Similarly, it's true for capital K and so y and capital Y as well. Because capital K dot by k, and this is at steady state and beyond steady state, is equal to n. So d k dot by k ss ds is 0. S doesn't change this at all. Aggregate output in the long run will continue to grow at the rate of n. But there is still a level effect. So a higher S will increase the steady state output and capital per worker for sure, right? But once you reach that steady state, the growth in small k will still remain at 0 and the growth in capital K will still be driven purely by population. Which means that S cannot change the long run growth rate in capital for this economy, whether aggregate capital or capital per worker. Okay. All right. A note. Just note this down. You probably know this already, but the slope of ln y shows growth rate of y, right? Since d ln y is this. Okay, so let's graph a few things. Let's graph two things in particular. Let's graph capital K and capital Y, small k and small, oh sorry, the axes are all wrong. This is t, and here you have ln capital K, ln capital Y. Here you have ln small k, ln small y. Okay, once you have reached steady state, so let's say you reach steady state at TSS. What happens before this is going to be covered in a separate video, but once you have reached this is not an important line in of itself. Okay, once you have reached this, what are these variables going to look like? Remember, they don't grow anymore, right, at steady state, which is to say they will be flat because their slope will be 0. What about this? Their slopes will be positive and they'll be parallel because both grow at n, which means the slopes of ln k, ln y will be equal. What do growth effects and level effects look like under this paradigm? If S increases, then this might move to this. And this is at the next steady state. In between, there's going to be a time where you transition to the next steady state. But I'm talking post-steady state here again. So you're going to be higher because your steady state value of k and small y themselves have increased. But note, no change in slope. But there is a rise in the level. So there is a level effect and there's no change in slope because there is no growth effect. And similarly, this increase in small s is going to raise capital Y and capital K after the steady state, but they'll continue to grow at the same rate.